And I'm just going to kind of reference the idea of just using triangles for today. Last week when we talked about having two triangles, we had 6 total things that had to be congruent. 3 angles and 3 sides. So last week we had, in order to show 2 triangles were congruent, if all sides and all angles were congruent. That's what we started with last week. This week we start to take away some of the information where you don't have to use as much stuff. We start talking more and more about easier ways of doing it. We don't necessarily have to show all 6 pieces being congruent because that just becomes wasteful. There's not enough time to do it, and there's no need to show all of it. Because maybe next week we'll be able to do that on the computer. So if all the sides are congruent and all the angles are congruent. What we're going to do today is we're going to talk about 2 other methods of doing this. We're going to talk about what's called side, side, side. And we're going to talk about what's called side, angle, side. If I'm talking about something that's just side, 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 how many parts are there? 3. So we've cut our workload in half. Shortcuts. And then we had the other thing that's called side, angle, side. Again, only have to have 2 sides and an angle in between them. And what happens here is we get into this, depending upon what thing we wind up with is how we're going to show the triangles are congruent. There's only going to be, I think, 5 total ways that we're going to show triangles congruent. Side, 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 bless you. Side, angle, side. Tomorrow we might get into angle, side, angle, 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 side, and then the last one's called hypotenuse leg. So we'll get into a bunch of those things. There's only 5 total ways of showing things that are congruent. And depending upon the triangle, depending upon the information you have, depending upon the given statements, it forces you to use one of them. It sounds really, really weird, but this progression sheet is going to be like everything you need to know. All right? Let me tell you about my head. Anyway, so here's what side, side, side stands for. Gee, I wonder. If 3 sides of one triangle are congruent to the corresponding 3 sides of another, then triangles are congruent. It's super easy to show you with a diagram. And that's what it would look like. Tick marks. Everything's got a tick mark that matches up. Excuse me. If 3 sides, excuse me. If 3 sides of one triangle are congruent to the corresponding 3 sides of another, triangles are congruent. What's that? Of another triangle. What did I forget? Oh yeah. This is why I teach
What?
This is kind of why I teach math.
What is that?
It's okay.
Look. Yes, I did that on purpose.
Another
Yes, congratulations. You did well today. Yeah. And then again on the other one, it's the same basic idea. If 2 sides and the included, this is different, angle of one, okay, included angle. The included angle. Included angle just means it's the angle between the sides. The 2 sides that are congruent have an angle between them. the angle between them is going to be congruent. So it's literally a side, an angle, and a side. And if two sides and the included angle of one triangle are congruent to the corresponding two sides and in the included, oops, I can't write like this side. See if I can spell another right this time. It is, but once I draw a picture, it's super easy. Two sides and the included angle of one triangle are congruent to the two sides included angle of another. It's a lot of words for something super, super simple. Again, this is what it looks like. Side, angle, and a side. Side, angle, and a side. Now, what I'd like you to do is get the boxes out. Very good. If I'm not mistaken, most of us, I think we should have 5 of them, right?
Yeah, 1, 2, 3, 4, 5, yes. Look for the vertical.
It doesn't work. So, what I would suggest that we do, as in a really, 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 really strong suggestion, bottom right-hand corner, we probably have nothing written in there right now, right? Okay. So in my bottom right-hand corner, I want to show you what I would do first before you guys write it out so you know space-wise. I'm going to do this. In my bottom right-hand corner, I'm going to write out ways to prove triangles congruent. Yes, and what I want you to do is realize that you're going to write out 5 different things. So you want to save yourself a little bit of space. Okay? Here's what I mean. I would write down that I know that I can show side, side, side. And what does that look like in a diagram? Well, it looks like this. What I'm doing here is I'm writing down what it is and what the visual looks like. And a side dash, side dash. It's just a little dash. You're not multiplying, you're not getting side cubed. We're not finding the volume of a cube. And then I do the same thing with side, angle, side. And remember, 2 sides and the angle in between. 2 sides and the angle in between. And that's what it would look like. Now, like I said, like tomorrow, Wednesday, we're going to add to it. We're going to add in angle, side, angle. Angle, angle, side. And hypotenuse, leg. So you see what I'm saying? We'll have 5 of them. There's going to be other ways of doing this. Right? So as we go through, you'll start to see the different letterings and the way the diagrams will look like. And each proof has its own way of making it work. It always depends on what you have in front of you to know what you're going to end up with. And we'll get there. So just so you know, those are the ones that we're going to have. Those are the only 5 we have. Okay? Not so bad? Yeah. Let's look at an example. Oops. Let's look at a given, proof, and a diagram. Okay? Go ahead and write this out. This is just in the notes, not on the progression sheet or anything. This is just an actual example of our first triangle proof. And we'll walk through how it sets up.
Okay. What are your sister?
I'm just writing down what we had in that square a second ago.
Yes.
And one of the things I want you guys to understand when we're working with proofs is that it is so unbelievably important that we have a very good diagram to go along with our statements and reasons. Reason being is that from diagrams, if you recall, there are certain things that we're allowed to infer. For example, one of those we have on our progression sheet says look for vertical angles. That's something that you can infer from a diagram. Okay? Excuse me. So when you have a proof, what do you think the first thing you should always do is?
Point out the given.
We have to get, okay, make your little T-chart, yeah. So we start with our little T-chart. Remember what that stood for? Statements. What you're saying, why. Okay. Now, as we go through your statements and stuff, that's generally when you would make sure that your diagrams are marked. Because then you know how to mark up your diagram and you know what you're leading yourself into as far as one of these possibilities are going to look like. Okay. So every proof starts the same. You always write down your first given statement. In this case, our first given statement is LM is congruent to NP. Why did I write that down? Because it says it is given. Does that statement have anything? Yes, sir. What's that? Statement reasons. Yeah. From this here, I just make sure my diagram is marked. LM and V. Okay. Nothing else I can do with those two statements right there. There's nothing else I can do with that diagram. There's nothing else left for me to do because that congruency statement isn't a definition, is it? It's not like it says that they're an angle bisector. So since there's nothing left for me to do with that one, what do I do next? Go to the next given, exactly. Go to the next given. Oh, is it wrong if you don't put the bars over the segments? No. Is it wrong if you don't label angles or label triangles? Yeah. And we are marked. So now you start thinking about ways that we know how to prove a triangle congruent. Well, we only know two, well, three, but we're not going to go through and try and prove all the parts. We know two ways. It's either three sides are congruent, two sides, and the angle in between. Is there anything in the given statements or anything in that diagram that you can infer that angles P and angle M are going to be equal to each other? There's nothing there that says that. There's nothing about them. Bless you. So you have to start thinking about other ways of showing something. When we go back into algebra, we'll come back to this here. True or false? Anything is always equal to itself, right? Is anything always congruent to itself? Yeah, because if this is an equal value, isn't that equal measure? Okay. So what happens here is there's this property in math called the reflexive property. The reflexive property basically is you are congruent to yourself. Okay? It's a nice little shortcut. Now, what I want you to do in a square is this. Look for a new one.
Is it you're writing in the blue box?
Yes, sir.
Is we write it in the sixth one?
I'm sorry, what?
In the sixth one?
Yeah, that's fine. Yeah, just put this in its own. And the reason that we're putting it in there because I'd say 80 to 85% of the proofs are going to be determined by what you're given, whether it's definitions and things like that. The other 20 to 15% of a proof is what you have to come up with on your own. And that part that you come up with on your own, gentlemen, the part that you come up with on your own is usually the inferences that you can make from diagrams. And in diagrams, one of the things that you can see is that you could share a side. Between those two triangles, what side is shared? Side. What side is shared here? AD, between the two triangles, the left and right there. Okay. This segment is shared between the two. So what I can do, whenever I see a shared side, what I would be able to state is this. BD congruent to BD. My reason? Reflexive property. The reason that I do that is because now I have one of the sides congruent to one of the sides of another triangle. It just so happens that it's the same side. And the only thing is with geometry proofs is that you have to be so overtly specific to things. You have to say something is there in order to use it. This is basically us saying, hey, knucklehead, BD's there, so let's use it. It's shared between the two triangles. Okay? So that's one of those things that we can infer from the diagram. Back to our picture. What's shared? Does it often say LN or NL?
No.
Nope, not at all. So I can say from my diagram, LN is congruent to LN, and what's my reason? Reflexive property.
I'm about to say am I right or am I wrong?
For what?
They're saying shared side.
No, you have to use what's called reflexive property.
Okay.
Okay? Do you have two triangles that are congruent now? Yeah. For what? What reason? No. These are the ways we prove triangles are congruent. Side, side, side. So now we can say that our triangles are congruent by writing triangle LMN NTL. And there's my reason. The only ways you're allowed to show that triangles are congruent are going to be one of these alphabet soups, if you will. Side, 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 angle, side, angle, angle, side, and so on and so on. Done. Again, notice, all you had to come up with was one thing on your own. Everything else, some version of whatever, is already on your progression sheets. It's a matter of what can you infer from stuff. Okay. What's that?
I don't think it's
Oh yeah, we're getting there. We're getting there. Okay. Sorry. You okay? Oh, you? Okay. Sorry. Sorry, I didn't mean to get ahead of you. We'll do the next one here in a second.
oh my god. You got
Good? Let's write our given, prove, and diagram. Let's write our given, prove, and diagram and see where it leads us. So, what's that? Yes, sir. Yeah. In other classes today have asked, is there any set number of steps that you're supposed to have all the time? No, there is no set number of steps. It always depends upon what information you're given, what information you can show, things like that. There is no one size fits all. Every proof is 5 steps. I know that we'll have proofs at some point in time that'll have like 11 or 12 ones. But then again, if we start thinking about it, it is really, really easy for that to happen because you could be given, I mean, I think on our progression sheets we have perpendicular bias or perpendicular, right? Yeah. If we have perpendicular, you say that you have perpendicular, and you say that you have right angles that are formed, then you say that your right angles are congruent. So right there are 3 steps you can get from that one given statement. So it's really, really quick that you can call your number of steps. But again, it's not that you have to come up with all of it on your own. You are slowly building into that. Okay? You're slowly building into it. Yes, sir. So in this one here, again, we start with our little T-chart. Statements, reasons. What you're saying, why you're saying it. First thing I write down is my given. So we write out our first given statement. It says B is the midpoint of AE. Bless you. Midpoint. Oh, that sounds like something important that has a definition, doesn't it?
Yeah.
On your progression sheet, what does it say to do when you're given a midpoint?
Segment.
All right, perfect. You know B is the midpoint of AE. All right, here's AE. What 2 segments are created that are going to be congruent to each other? AB, BE. So what do? I mark it and I write it down. This definition tells me AB is congruent to BE. What's my reason? Perfect. The reason is definition of a midpoint. Again, you are given something. That something happens to have a definition to it. That definition says, hey, knucklehead, segment's going to be congruent to segment somewhere. Find it. Okay. I found it. AB congruent to BE. You should be. Yes, sir. Oh yeah, you can go A, E, B, B, A. Yeah, it does. I'm not really worrying about the lettering. As long as you say the right segments, I'm fine. Okay. Sometimes your lettering can get off, but as long as you're saying the right thing, we're okay. Is there anything else left I can do about A, B, and B, C? No. Oh, I'm sorry. That's what you're saying, B, E. I'm sorry. Good morning. Go to the next one. B is midpoint of CD. Once again, that definition, being a midpoint, means somewhere in the diagram I can mark 2 other segments being congruent to each other. I wonder what they are as well. Hopefully I've labeled them correctly this time. According to my diagram now, DB and BC have to be the same.
Why is that? Because it's the definition.
Very good, Joe. Very good.
It's probably going to be.
Okay. Now, again, we're at a point now where we are able to use the given information, just so happens to be two definitions that we just reused. I know that I've marked my diagram, I've got two sets of sides congruent, so I look at ways to prove triangles congruent. Well, I can get all three sides, or I can get side angle side. Well, there's nothing in here that can get me AD and EC. There's nothing. But what do we have? We have vertical angles. You guys remember that?
Yeah.
On our progression sheet, there should be a picture that kind of looks eerily similar to that, doesn't there?
Yeah.
And that was one of the things that you can infer from a diagram. It says, look for vertical angles. Hey, look, vertical angles. So what we would write out is the two angles that are congruent to each other. Well, the angles that are congruent would be ABD and EBC. The reason that those two angles are congruent is because of what? Vertical angles are congruent. There's that inference that you get from a diagram.
Oh my God.
So, in this instance, if you really go down to it, these 5 steps, you only had to come up with one of them on your own. And the only one you had to come up with on your own was that vertical angle part. Because everything else was a definition. Even the last step here, how do we know that they're congruent? What's the reason? What's the reason these two are congruent? It's one of these two. These are the only two ways you can show triangles are congruent. Side angle side. So now you're done. Your two triangles are congruent. So this one had 6 steps. The total of the 6 steps, one of them, you had to figure it out on your own. I mean, a lot of times students get freaked out when they see proofs because there's a lot of words and a lot of writing and they're not sure what to do. But I try my best by using these progression sheets because it takes the I don't know what to do out of it, because you have all of the information in front of you. How do you use it? What's your first step? And you just kind of work your way through it. Obviously, lettering and all that's always going to change. The diagrams are always going to be different. But the basics of it are all the same. What can you say from the definitions that you're given? Did you mark your diagram? And what's your next step? Okay? Amen? Just to be on the safe side, I want to make sure that we have, I know we talked about it, but just if you don't have this one written out,
Given a midpoint?
no. Yeah. Make sure, do you guys all have if given perpendicular?
Yeah. Right.
Plus right.
Okay, all right. I just wanted to make sure. It's one of the ones that we see from time to time people forget, okay? All right, well, then you already have that one, so let's do this. Given.
What?
Nope, this is proof.
I would be good, but and I would be good.
All right. Let's try this. Go for it. You have all the information in front of you. Try it. AC is perpendicular to BD. D is the midpoint of AC. Prove. Triangles ADB and triangles CDB are congruent to each other. Okay? Yep. Yes, ma'am. We have a Batman and a Captain America.
Not a
You know what?
Batman's better.
There you are. All right, take a couple minutes, go through this, look at your progression sheet, and we are running a few minutes short here. First things first, statements, reasons.
All right.
Given AC perpendicular BD. According to my progression sheet, that tells me then to state the two right angles that are formed. So I go to my diagram. The two right angles become angle ADB and angles CDB are right angles. That's literally what we are writing out. What's the reason then? Perfect. You're just reading it verbatim. Definition, perpendicular. The reasons of what we write out, how we write it out, doesn't change. What changes really is just going to be what letters are they of the angles. Okay? So now I know that those two right angles, well, according to my sheet, it tells me how to say that those two angles are equal to each other, are congruent to each other. It's okay. It's new. Yes, sir. I just put it on the calendar. All right, yeah, it's up there. So then we have angles ADB is congruent to angle CDB because all right angles are congruent. So just by knowing that I have perpendicular, that tells me right away that I can do two things. I say that they're perpendicular. What right angles are formed? Those right angles are congruent. Have I completely used up that given statement? What do I do next? The next given statement, which happens to be midpoint. Okay? So write it. Write it. D, midpoint. Given. If D is the midpoint, what does that do to AC? Which parts? I mark it. Definition of midpoint. In just that, you didn't have to think of any of that. Everything was on this sheet of paper. It tells you exactly what to do. Looking at your diagram now, you have a side and an angle, which means you have to come up with another side. What side do you have? According to our stuff, though, BD. I have that reflexive side, don't I? The only thing you had to come up with on your own is that you had a reflexive side. Again, what can you infer from the diagram? Well, according to my progression sheet, it says, look for vertical angles, look for reflexive sides, the shared side. I would just write it out. I know we're running out of time here, so I would just say BD. And then your triangles become congruent because of, try again.
Side.
You guys have to trust yourselves that you can read a sheet of paper to do these. On
What if you do?
homework, I just put it on the calendar because I forgot to do it earlier. There are 4 of these for you to try out. I think they're about five steps or so. On page 230, I want you to do numbers 9, 10, 16, and 17. There should be absolutely nothing in those proofs that come as a surprise. I'm pretty sure we hit an example of every possible scenario for all of those. Okay? Excuse me. We'll get into a little bit more of this stuff tomorrow, obviously, over the course of the next few days. They do become a little bit more complicated throughout, but again, as long as you've got that progression sheet there, it tells you what to do, guys. Don't forget, as we start to add more and more to them, take a picture of it with your phone in case you do lose it. You don't want to lose all 7 of these things that are on here. You have a backup file, if you will. Okay? Not a bad idea. What's that? Or you copy it on the copier, you email it yourself. I think.